Now, when it asks us to solve for a variable that is being logged, we first have to use log properties to get one single log on one side. So here you can see the first example is easy to solve for. It already has one log. I can immediately convert to exponential. How do I convert to exponential? Log rule. And then you solve for x. Now, on the right-hand side, these are a little bit, well, the top one is a little bit more tricky. Why is it tricky? You have two logs. So your first step is to combine those into one, to condense into one. So this is the example I'm going to do. I'm going to do this one. How can I condense those two logs? Yeah, when I'm adding two logs of the same base, I can condense them into one by multiplying the terms. So this it turns into log base 3 of 4 times x. So if I'm trying to solve for x, it's currently being logged. How do I get something unlogged? You log roll to convert into exponential. Good. So where do I start my log roll? With your base of 3. And which way do you go? Towards the equal sign and around. So what am I going to write? 3, then we go to 2. Then what's the last thing we hit? Good. So 3 raised to the power of 2 is 9. And then what's our last step to get x alone? So here, and we can leave it in fraction form, my answer is 9 over 4. Have we done this before? Yes, kind of. There was a couple problems where we did actually solve for a variable. So you guys go ahead and on the top, do the first example we skipped over here and do the last example. Do these two examples. Yes, the first example, you guys got what again? Yes, so here we can immediately log roll because the log is by itself. We have 2 to the 3rd power is x, 2 to the 3rd power is 8. So that's what x is. Now what about the second example? What did you guys get? X equals 20, yes. So what you did was, you're lucky your log was by itself again, so you can immediately roll. So 4 to the 2nd power is equal to x minus 4. So we just have to add 4 over. And then it's 16 plus 4, which is 20. Any questions on either of those? All right. So on to the next portion. What do you think happens when you're solving and there is a log on each side? So they're on each side of the equal sign though. How would I combine them? So if we remember our log properties from last class, if I had log base b of m set equal to log base b of n, what does that mean? M is equal to n. If you have logs of the same base set equal to each other, the terms being logged are the same. So here, it's basically like you're canceling out the logs. You can only do this when you have logs set equal, okay? Only when you have two logs set equal to each other. So what we do here is we have x plus 3 set equal to 2x minus 2. And then I solve, I subtract x over, I add 2 over, and x is what? 5. 3 plus 2 is 5. When you have log of a same base, set equal to log of a same base. Only.
What if you had a log equal to the next one?
Different. Totally different.
Would you have to like log roll one of them? And then
Probably. It depends on the situation. Depends on where x is, I should say. All right. So I want to do the hardest one, though.
I don't.
What, you want to do the hardest one on your own?
Yes.
Is that what you're saying?
Give us a chance.
Oh, you do want to do the hardest one on your own. Okay.
No.
You're never really alone.
Don't listen to Haley. No.
And Austin was saying it too.
Austin doesn't know what he's talking about.
You're never really alone.
Okay. So, do I have a log set equal to a log?
No.
No. So can I immediately cancel out these logs?
No.
No. What do you think I need to do first here? Ah, yes, you have to combine them first. So how can the ln, the natural log of x, plus the natural log of x minus 3 be combined? Just x times x minus 3. So now do we have a log set equal to a log? Yes, we do. So what happens? You can cancel, and it's just x times x minus 3 set equal to 9. Now, what do we have to do next here? Distribute the x. Yes. So, x times x is minus equals 9 still. So I'm going to tell you, anytime you are multiplying x's, so multiplying variables or dividing variables, this is when an extraneous solution can occur. So, when an extraneous solution can occur, this is when you, yes, have to check your solutions. Does that make sense? So here you recognize we're multiplying x times x. We're multiplying our variables. In the end, we're going to have to check for extraneous. So, what do I do to finish solving for x here? You set them equal to 0. Why are we setting them equal to 0? It's a quadratic, yes. So to solve a quadratic, how do we solve it? One of you is probably going to have to move.
You have to square root.
You have to, no. How do you solve a quadratic?
I want to pull out DCF.
What is it called to solve a quadratic? Factoring. You have to factor. That's why we got to set it equal to 0. So we're going to subtract 9 over and set it equal to 0. Now, what multiplies to give you negative 9, but adds to give you negative 3?
Does it multiply to get 9?
Does anything?
No.
No. So what do you need to do?
Quadratic.
Oh my goodness, the quadratic formula.
Our good old friend.
Which is x equals negative b plus or minus the square root of b squared.
Minus 2, 4ac over 2a.
Beautiful.
Oh, my favorite.
So this is our a value of 1, our b value of negative 3, and our c value of negative 9. So this is going to be 3 plus or minus the square root of 3 squared minus,
3 squared.
what's that?
It's -3.
Oh, is it? So what is -3 squared? So does it matter if I put a -3 there or not?
No. Guess not.
I'm kind of lazy, and I skip that. Oh, I put an A, though. 4 times 1, and C is -9 all over 2 times 1, which is just 2. So 3 squared is what?
9.
Minus 4 times 1 times -9, so it's a positive. What's 4 times 9?
Yeah.
So what is 9 plus 36?
45.
45. Now, can the square root of 45 be simplified?
No. No.
What goes into a, I know you have very little room. I'm very sorry. If you need to write on the back, you can, or write in your notebook, that's fine. How do you simplify 45? What goes into it?
9.
9 times 5. Can 5 be simplified? Can 9 be simplified? And 2? So, what are our pairs here? Pair of 3s, so that goes on the outside of my radical. And what's my leftover?
5.
These are my solutions.
Would you not combine the?
No, because the second 3 has the square root of 5 on it. So they're different terms. Lucky enough for you, you're not going to have one this hard on your exam. And you will have your calculators. Now, what did I say in the beginning if we're multiplying or dividing x's? You could end up with an extraneous.
So now we have to check.
So now you have to check. I'll give you a little hint though, a little workaround. If in your problem you have the log of just plain x, which do we somewhere in our problem?
We do.
What can that x not be?
0.
0,
1.
1, or
Anything less than 0.
anything less than 0. So it can't be what? Is one of these solutions 3 plus 3 square root of 5 over 2 or 3 minus 3 square root of 5 over 2? Is either one of those a negative number? Yes, which one? Subtracting 3 minus 3 square root of 5 is negative. So we boom know that I do at least have one extraneous solution of 3 minus 3 square root 5 over 2. I know for sure that one is extraneous. I need to check to see if the other one is extraneous. How do I check to see if a solution is extraneous? Plug it back in. So when you're showing your check, all you have to do is show me that you're plugging it in. So ln of 3 plus 3 square root 5 over 2 plus...
This is from Miss Nichols.
Oh, how cute. Thank you. She's so sweet. I need some water from Miss Nichols.
Our old principal.
No, from the new teacher.
Oh, interesting.
Ooh.
She teaches WAP.
She got everyone a flower.
No, just we talk. She's right over there. Yes.
You know where?
All right. So all you need to do is show yourself plugging those values in and then put it in your calculator because you are going to get a calculator on this test. So does someone want to plug that in for me? Someone did first period for me. It was nice.
1, 2, 3, nose goes.
So, Miss Sunderland. Miss Sunderland.
Yes.
So, x cannot be less than or equal to 1.
Yes.
Ever. Like,
No, that's a lie. No, 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 no. X cannot be 1 and x cannot be less than 0. It can be all of the numbers between 1 and 0.
So x cannot be less than or equal to 0.
Yes. but it cannot be 1, but it can be
anything
between
in
those two.
between.
Mhm.
That's interesting. Okay.
My sister just What do you call it? My sister just said that to me. I'm gonna get drunk AF after this class.
So yes, when you checked it, they are equal. So it works. So your one solution is x equals 3 plus 3 square root 5 over 2. That is your one solution here. All right, so you guys need to go ahead and do these two leftover examples.